people when we talking geeky EUC stuff. I have got Dr. Benny Tristsch, trust him, he's a doctor, on the line. And I have been watching this guy since, man, the early days of Bryform. You and Sean, when you guys you were in video back then, and I know you like your doctorate is about video or has video.
Yeah. Graphics remoting.
Remoting, that was what it was, graphics remoting.
Yes. Yeah.
But through the years, I've watched your tests. They started with Sean when you guys did your thing, and then it became more and more complex. But something you presented in the spring when we were at the UC Masters retreat had the room packed, and I want to talk about it because it is so labor intensive, and I want to understand like why. Right. But let's start. Go ahead and do an intro, and let's start with what you're doing now. Just a quick summary, and then I'll start poking because I got questions.
Very simple. My name is Benny Tritsch, and I'm in this EUC industry since almost 25 years. And I still enjoy it, as you can see. And I would have never dreamed of staying in this industry for such a long time, or in this particular market, because as you said, I did my PhD thesis in computer science in graphics remoting and
what year
audio
was that?
Video encoding for interactive communication like we do now. So
yeah. What year was that, Benny?
Oh, that was in the 90s, mid 90s.
Yeah. Think about that, right? I mean, even the computers of the mid 90s, right? Like a 95, 96, right? We're talking Windows 95 on 386s.
Yes.
Graphics were 8 and 16-bit, right? So when we talk about video remoting, there couldn't have been many people focused on video remoting in the mid 90s.
Yeah, fortunately, I was at the Fraunhofer Institute on a PhD program and had like up to 10 students who helped me with that. They did their diploma theses and master theses and stuff like that.
Oh, cool.
So it was amazing time. And at the beginning, nobody thought that this will ever fly because they said, oh, number one, graphics remoting, why would you do that? And number two, audio video communication on a computer, why would you do that?
People had no idea, right?
I could come naked out of my bathroom and people would be able to see me. Yes, welcome to the world that we have today.
Oh God,
it was true. So interesting.
But it's so different. It's so different, right? Now, when you had told me that was what your doctorate was in, everything clicked when you told me that, and I looked back at all the presentations I watched. And you've done a lot outside of video, don't get me wrong, but the video stuff has always been really heavy on the technical side.
Yeah,
you know, and what you just did, and I want to talk. This is what I wanted to get you recorded about was. You presented that data, you and Ruben, at the EUC Masters retreat. How did you guys title that? What was the title of that presentation?
Like
video performance versus like user experience versus cost.
A deep DAS analysis, understanding performance, price, and user experience. So that was the title.
But what he didn't tell anyone, he sucked us all in, was that him and Ruben were looking at specifically high-end video performance, 3D rendering, high-end video. And there was something interesting about it. And I want to understand it from your perspective. I especially want to start with this one question. You actually watched the videos that are being rendered and compared them, but it wasn't like you were using some mathematical algorithm. You did it with the Mark I eyeball.
Yes.
And you scored it somehow?
Yeah, unfortunately, we still have to do that. And what I learned over time is that it requires a lot of training. So even when I was at the Fraunhofer Institute and doing during my PhD thesis, my wife, she got upset when we watched a movie and I was able to see the artifacts. And she said, this is not fun. And I said, oh, I can see all these little things that are happening that should not be there. And because if you have a trained eye, you can see that.
Oh, and,
it's very helpful. And I learned that when I try to sort of outsource some of the work that you just described, like reviewing all the videos, and people get tired. because
Yeah.
it's very, very hard to do and stay focused on it. And it also requires the right tool set, and can dig into that in a minute.
Well, let's start with that basic thing.
Yeah.
You know, you guys were comparing a bunch of different hardware types, virtual hardware types in different clouds,
Yeah.
running a series of videos that you had, so you would be running the same things over and
Yes.
over. You were looking at cost, the utilization of the machine, the normal stuff that IT folks look at, but
Yes.
then you did this layer on top where you used your eyeballs and you said, I'm watching, here's the original, here's what I'm seeing. And you came up with a scoring system for that?
Yeah, yeah. Let me tell you why. Let me walk you
Okay,
through
yeah. Walk me through that a
the
little bit.
methodology, like the maturity phases of what I'm doing. I mean, just think about a rock concert. Make it very simple. If you go to a rock concert, it has certain characteristics, like who are the opening band and the headliners, the set list and the concert duration, the number of attendees, and all that. It's like telemetry data.
Mhm.
And if you have that telemetry data, it doesn't tell you how good the concert was. Because when people attended, when people are listening to the music, that makes a very big difference to what the telemetry data is telling you.
Mm,
Everything may be set up very, very nicely, but maybe the sound sucks.
mm.
Maybe the band does not perform so well, and the audience is annoyed. I call that the annoyance factor.
Okay.
And this
Okay.
is exactly the difference between what our monitoring systems in the IT world are doing today. They look at the telemetry data,
Yep.
but typically they do not look at the real user experience, because this real user experience is really hard to capture.
Sure.
Pretty much as it is to be a wildlife camera person and then capture the footage that you need for a documentary,
Yeah.
like on Discovery Channel.
Yeah.
So you need a lot of equipment and you need a lot of skills to do exactly that job, so that you are able to transport these emotions that
Yeah.
you see in an episode on Discovery Channel.
Well, and
And that's the
quantifying
hardest thing to do.
quantifying that user experience, as you said,
Exactly.
what we've
Exactly.
done historically in the EUC space, and this started 20 something years ago, but we historically would go, here are the things that we know technically that lead to a user complaining, right? We built this environment, we ran it for a year, and now we know, okay, whenever that site gets over X number of milliseconds, we know that they start complaining, latency. Whenever the CPU is above X or there's disk contention,
Exactly. It's telemetry
we
data.
so we're taking all that today. What we've done is we've had 20 years of looking at it
Yeah,
and going,
yeah, yeah.
when these things happen, users get mad. So we're gonna score on those, we're gonna alert on those, we do all these things. But what's different about it when it comes to high-end video is that there's no good way with a
Exactly.
remote protocol to say, do I actually see the video the way the original was? Is that right?
Yeah, that is absolutely correct. And so the rock concert and the wildlife camera person, those were the two first phases in the majority plan that I have. And number three is like looking at crash testing in the car industry. And they came up with a bunch of hard criteria so that you can measure what it means to the end user, the driver in the car, when something goes wrong, and how good, how well the driver is protected. And that's exactly what they try to measure. And they use high-speed cameras. Guess why?
Mhm.
It's high-speed cameras that they're using. They're using the sensors. So I'm pretty much using, well, the methodology that I learned in science.
Mhm.
Plus, I'm using those applied methodologies out there in a different market. And I was trying to adapt it to our market. And to your point, there is no common set of criteria what good user experience is. And
Mhm.
over the years, I was able to identify those. I call that the annoyance factor. So,
Mhm.
what are these things that annoy users? So, time to first byte. How long does it take to turn on the machine and something shows up on the screen? the application load time, the application stability, user input delay. How long does it take from click until something shows on the screen?
Yep.
Then we have the graphics APIs that are supported, and that starts coming to the point that you made earlier. If the graphics API is not supported, one of the graphics APIs, that is not good for the user. Unfortunately, we typically cannot see that in the telemetry data. If the application doesn't start, it's good for us because the CPU load stays low. Wonderful. So if the user experience sucks,
Yeah.
it's good for the IT pros who are managing. The next thing is media format supported. Do the videos crash or not? Are they out of sync? What happens with that? And the distortion of media, that's exactly what you mentioned. So sometimes, coming back to the wildlife cameraman, sometimes I was able to record stuff that looked like I'm in a psychedelic movie. It's like you find a very rare animal out there, and suddenly you have this footage because you're able to record it. You show it to end users and they say, oh, this is exactly what we've experienced in the past. You show it to the admin says, whoa, I've never seen that before. Can you imagine
those videos? You showed those videos in your presentation. And
in the past it was outtakes. Today it is the most interesting things.
and I want to frame this a little bit. You know, your specialty is video, and this is really about that, both ends of it. Can I render it on the back end? Can I do what I need to do on the back end processor wise and all that? Great, right? Because we can get telemetry. Well, some of the manufacturers give you telemetry, some are working on it. But like we at Login, we can get telemetry and do all that. But when it comes to high-end video, when it comes to 3D rendering, it's about the human eyeball. And we don't have a way to score that today, right?
And let me just finish there. There are three more. Screen refresh rate, screen resolution, display size, and session availability and resilience. Those are fairly simple to measure with monitoring systems. Because, we can measure the screen refresh rate. Maybe not at the endpoint. At least we know what it is at on the sender side. But when we come back to the distortion of media, I did some research, and it was interesting for me to find like how many recording screen artifacts are out there in the market, because there are other industries that, well, TV industry and media industry, and they rely on good quality, and they have like block boundaries, tiling, smear artifacts, blurriness, color artifacts, mosquito noise, ringing, choppiness, floating, jitter, flickering, slow motion, video stuttering, micro stutters, freezes. Like it's a complete plethora of terms.
Well, and you've got a list of all these terms of different types of video failures.
Yes.
But every user, including us IT folks, have seen each one of those.
Absolutely.
We've had it on our phone where there's a pause, you lose a keyframe, and then you get the weird psychedelic thing. There's always
like
something.
A smearing effect. And
Why is it, Benny? And this is just my own ignorance on the video side and on really measuring video. I know that our eyes, sometimes you have to put eyes on it, and you as a person have to kind of subjectively score something, and that's where we are. Will there be a way in the future to measure that? Because you'd have to compare. What you're doing is comparing the two videos, the real and the one that came over the protocol from the VM.
Yeah.
Will there be a way in the future to measure that, do you think?
I think so.
Programmatically?
I truly believe that machine learning is going to help us a lot.
That's a great use case.
I had conversations with people who are very familiar what machine learning can bring to the table here, because what I'm doing with my naked eye now, this could be something that we train a machine learning algorithm to find exactly those artifacts. Well, so today I have to find them.
Yeah, but you've got the list of things that you can teach it, right?
Yes.
How to spot that. And
I have all the videos. I have the content, because like you said, Sean and we started that like 10 years ago, and I still have all the videos.
Yeah.
So I have a huge video repository of all these little effects that can happen. Now,
Yeah.
this is ideal material. It's like I was waiting for machine learning to come. It helped me
Yeah.
with that.
Well, and it'll be different, right? Because if you think of, people who think of AI and machine learning today that aren't deep into it, right? They think of Chat GPT, and those are using natural language
Yeah.
processors and they're learning languages and stuff, where this will almost be a purely mathematical thing,
Yes, true.
right? It'll have to be a purely mathematical thing, and to teach it to look for those different types of
Like,
failures in the
yeah,
video.
giving the machine learning algorithms examples during the training phases. Okay,
Yeah, yeah.
this is a smearing effect. And here we have different videos that show the smearing effect. Now, can you
Yes.
identify the smearing effect if I give you 500 more videos?
Let them,
And
oh
that's
yeah,
the idea.
let them find at the pixel level what's going
Yes,
on.
yes,
That's,
yes.
yeah, I hadn't thought about it from a machine learning perspective, but that's interesting. But let's go back, because
Yeah, sure.
you don't have a big data center with a machine learning
Yep, yep.
algorithm behind that curtain. How do you do it today? Because let's just talk that process a little bit. And I know that you're a scientist, so you've probably got a very methodical process. Someone comes, or you're looking at
Mhm.
something and they go, we have high-end video, our customers need it bad, we're always worried about this, we're doing it remote, we're doing it centralized, then if they switch, they get freaked out. What are you doing today to show these customers, right? What's your process in a situation
Typically,
like
what
that?
I do is I build together with those customers. I build reference environments or POC environments.
Mm-hmm,
In most cases, it's long before production.
mm-hmm,
So typically, I enter the game when even when the larger vendors are in prototype phases or when customers are planning to do a migration, and
mm-hmm.
they do their POC. They ask me to join them, to join their team, like a QA engineer, basically,
Mm-hmm.
or a crash tester, because a crash tester,
Crash
they
tester.
also do their job long before the car is finally manufactured and released, well, to the market.
Yeah.
So this is why it's always such a secret thing when these crash testers do their job. And I'm under NDA with many of the vendors, with many of the customers I'm working with, and I help them to build a reference environment. And then we record also a reference environment which is not looking into the future but is looking into what they have today. So we want to have the existing today's performance they get. Maybe we also want to know what they get when they use a physical machine, because the ultimate competitor of a remote desktop is a physical machine.
It's a
It's
high-end
not
video
one
machine. Yeah.
vendor against the other. Absolutely not. The biggest competitor is the physical machine.
Yeah.
And so I run all these synthetic tests. These are my crash test dummies. I call them simulated workloads, simloads. And I run these simulated workloads, and they represent different media types or graphics APIs. To your point, it could be like high definition video. It
Sure.
could be like you saw in at Masters Retreat. It could be a CAT cam application. And so I run those on different systems, and then I have a player, a video player on steroids that allows me to put the videos side by side, because the human brain cannot remember what the performance was like when you watch a video an hour ago, and you cannot compare it so easily when you run it now. So you need to run them side by side, and I add the telemetry data.
Differentiating between those
Yes,
two. Yeah.
exactly. And I mean, selecting those videos that I compare, this is the tricky part,
I was about
because
to say, does it have to be a specific type of video? And does it depend on the customer? Like if
yes,
it's
absolutely.
engineering customer is
Yeah,
different than people who do video
yes.
editing
The
for YouTube or
pre-selection
whatever.
of the synthetic workloads depends on the user personas that the customer wants to learn about. So if it's a CAD CAM designers,
Yeah.
they don't want to know how to interact with Word.
Yeah.
So that doesn't matter to them.
It's just like our synthetic workloads. You have to make the workload match what the user's doing.
Exactly,
Yeah, yeah,
exactly.
okay.
And
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 here the
that's
video selection is probably whatever you're going to run is probably one of the biggest decisions that has to be made when you're
Absolutely.
going to do this.
So I have in total, I have like 60 of those synthetic workloads now.
Mhm,
And but I can add custom synthetic
mhm,
workloads like Ruben did.
mhm,
So we're using the same methodology, but not totally automated. Now the user clicks following like a script,
mhm,
like do this, do this, do this. Always do the same thing because sometimes automating all these applications is just too hard to do.
mhm.
And they're so the customers have so specific requirements that you don't want to automate that. It's good enough if you do that manually, if
Mhm.
you are, well, strict enough, if you're
If you're following the same steps,
exactly,
and
exactly,
in your case, it's
very
not like
structured way of
yeah,
doing it.
it's not like you're trying to generate 1,000 user load.
No.
You're trying to, especially now when we look at cloud, right? We might test a virtual machine type, and we might, if it's multi-user, we might throw more users at it,
Yes.
but we don't run 1,000 user load test anymore.
No,
You know,
no. The noisy user testing that I do maximum is 10 noisy neighbors on the same machine. It's not like in the past where we had
yeah,
physical machines with like 100 or 200 users on
yeah,
that one box. That does not happen
yeah.
anymore.
It's very
So
different.
that's
It's
all over.
very different.
Yeah.
So let's just, you know, and I know I only got you for a little bit, but this is so interesting to me because I'm basically an ignoramus that fell into technology. But you know, when I watched the videos that you were showing at the EUC Masters retreat, and that was interesting to me. But again, you create a score. So you subjectively view the videos and you have a score system that tries to make it as objective as possible. And then you started comparing it not just to how did it perform, you started comparing it to costs and all this other stuff,
Yes.
right?
And to be honest with you, Ruben and I, we also used the Login VSI
Oh,
score. That was
yeah,
one
yeah.
of our scoring mechanisms. I have some of my workloads, very specific workloads, that create a score, and we have other applications that create a score. This
Hmm.
allows us to produce a real score. But on the other side, I'm running all these other simulated workloads that are rather good for creating artifacts
Mm,
or anything that annoys the user. There
yeah.
is no real score behind that as of now. It's
Mm.
more like the comparison. And guess what? It's CEO compatible because I have a button that hides the telemetry data and only shows like the result. It's like the boss,
Oh,
and then you only have the two videos, and you can put a price tag on each of
yep,
those videos, and then you can go in front of the decision makers and say, look, this is what you have today.
yep,
This is what you're planning to do. This is going to be the performance, because we're also using WAN emulators to simulate
right.
crappy network
Yep.
conditions. And this
Network
is what your
jitter, high
users, yeah,
latency, whatever. Yeah.
exactly. This is what your end users are going to see.
Mhm.
I mean, you are the decision maker, you know? If you're
It's
happy with that, okay, you go for
it,
it. I have another solution that may be a little bit better, that may be a little bit more expensive. Here it is. Just compare them.
yep.
Okay, dear Mr. and Mrs. Decision Maker, now do your job.
You
I'm
get to
only the
now
messenger.
now you get to make the decision. Yeah.
Yes.
It's funny how in IT, and I think well, most of us, especially that have been on the consulting side and then on the software and on the vendor side, on my case, how quickly you realize, especially in your early consulting days, that the decision makers, they don't want a 50-page report.
No,
Right? Initially, you think that's what it is, but
no,
no,
it's
they
not.
want it boiled down. They want it to the barest. Show me A, B, and C. Why is it only these three? And what's the cost of each?
If you want to buy a new car, but you're not an expert, do you want all the nitty gritty details? No, you don't. You
No.
want to have an overview. You want to, well, it must fit into your requirements. It
Yep.
must fulfill the use case that you have.
Yeah.
You
Yeah.
don't want to buy a muscle car if you want to go out hunting. and
Yeah.
get all your equipment on your truck.
We-
A muscle car is not what you want in this case.
Yeah.
So, and this is exactly what we have to learn. We need to look at the use cases and adapt everything so that a decision maker who is not an IT person can make an educated decision. If they want to know more, I can go to the IT folks and we can discuss the telemetry data and everything.
Mhm.
That's another conversation then, and that brings us to this level 4 of my maturity model, and I'm not there yet. And my big, well, where I want to be is where Mythbusters was, because
Ah, yeah.
they always did it in a very, very scientific way. They
Mhm.
had a big team that was working behind the scenes to set all these experiments, because in the end, it's an experiment.
Experiment.
There's a myth out there, like you said at the beginning. Hey, we have a theory. It's science. Now let's find out if, well, this theory holds. And I mean, in the end, the myth was confirmed, the myth was plausible,
Yeah.
or the myth was busted.
Yeah.
I pretty much do the same thing. The problem for me is right now, I'm at the level of the crash testers. So the results, the way I present the results, are not very sexy.
Yeah. Yeah. It's
So
very, yeah, yeah.
Mythbusters, that was a very different
They
story.
they made it, they took those things and they made it sexy and entertaining,
Yes.
right? Because
Yeah.
that was their job, was entertaining.
And
But the
exactly,
sexy
that is
thing,
the
yeah.
next level where I want to take this. And that makes it consumable for a large group of people. And the number of people who want to use our EUC technology will grow, because
Mhm.
in case Windows 365 will be successful and Microsoft will build a lightweight Chrome-like
Mhm.
endpoint, and these machines boot
Yeah, it
into
would be,
Windows
yeah, boot to
365.
Windows. Yeah.
And I had long conversations with the Microsoft folks, and they said, we don't want to tell people that this is remoting. We
Mhm.
just want them to use it like they use Netflix.
Yep.
They don't know that there's a remoting technology behind
No.
Netflix, and
And
they
all
should,
types of, and all
or
types of other
streaming
things that they're
technology.
doing in the stream to optimize it and
Exactly,
all that. Yeah.
exactly.
I want to hit on something because you said a word, you said sexy, and that actually
Sorry
led.
about that.
No, I like it. Oh, you're a very sexy man. You're a sexy doctor. Um, I wanted to get it. I wanted sexy. To me, when I hear anyone bring up GPUs, I always think that's because they're sexy. People love to talk about GPUs like they solve a lot of problems. And being a video guy, being a video person, I'm not a video person, but I have noticed, and it makes complete sense, that people will add, let's say they'll change a machine type, everything else is the same, but they're adding a GPU. And they'll notice things like, well, my processor utilization went up. Well, yeah, because now you're handing off stuff to the GPU, but your processor also has to do that math to do that, and then
Yeah, it's a
other
dispatcher.
things. Yeah. Do you think that, and especially in Azure and let's say Amazon or Google, wherever we want to look at a hyperscaler, do you think that GPUs are being over subscribed? They're actually, people are going out and buying GPU virtual machines that they actually don't need very much, or is it a small percentage of those that spend for the GPU?
Right now, it's a relatively small percentage because there are not so many GPU accelerated VM types, or not large quantities out there. I was
Yeah.
I was trying to change my quota for some of my Azure subscriptions, and I have ongoing conversation with Microsoft support, and they're not available.
Wow.
So it is painful to
Mm.
get the resources that you need. But some of the videos in my simulated workloads, they don't run without a physical GPU
The
or a
physical
virtual GPU or whatever it is. So the CPU cannot do it alone. And that is also true for many applications. As soon as you start using OpenGL as
Mhm.
your API, they just crash, or they
Yeah.
didn't even start. They crash silently. You don't even see
Yeah.
an error message. And that annoys users very much. And so, yes, you need GPUs. The question is, how much GPU capacity do you need?
Mhm.
Because if you look at the high-end GPUs today, no, the average user does not need that kind of GPU performance. But
Okay.
try to go out and buy a physical PC, laptop, or mobile phone without a GPU. It's not
Mhm.
possible.
No, they're all there.
There's a reason for that. There
Yeah.
is a reason for that.
Well, and especially if you're buying it as an individual, it used to be that computers, PCs, laptops, right? They were made for the workplace. We used to send them, what does IBM build for, Ford Motor Company? Now the electronics that are laptops are driven by consumers, right?
Yep.
Yeah, I use it at work, but I'm watching, like you said, I'm watching Netflix or I'm watching NFL Sunday Ticket.
Yep.
They want that type of video performance. And so sometimes, I don't know, I look at it, it's like every customer I talk to that brings up GPU, and I'm like, isn't this for a small county in Indiana but it's
Uh,
for the school district? What are you guys doing with the GPUs? Are these people doing video things? They don't know. They think that the GPU,
yeah.
because it's become so standard on every other device, that they should have it in the cloud, have it in a VDI instance. And a lot of
From the
time, I mean,
test,
that
yeah.
Citrix paper just came out, right? Where they were doing, who was it over at Citrix? Alan Formansky. He
Oh,
did that
okay.
white paper with Microsoft and AMD, and he basically goes, well, the better performance was a machine that was only that much more expensive than the next one, and it was huge performance help, right? It was a big bump, but don't do the GPU, right? For them, they actually found in a non-video workload,
Yeah. Yeah.
stay away from it. And I'm always concerned with customers they're focused on GPU, and if they're not an engineering company, somebody using ArcGIS or 3D AutoCAD stuff, why are
I
you?
even have results that show exactly what you describe, comparing Windows 365, where you'd think, oh, this is not a very powerful machine, but
Mm-hmm.
they have relatively modern CPUs they're using for Windows 365. And I compared it to an NVV4, which uses an old MI25 AMD GPU. Now, running some of my simulated workloads on these two machines and comparing the results, well, what can the CPU do when it finds a GPU? Oh, it offloads some of the code to the GPU because this is what the GPU tells it to do. Because it registers as soon as the machine boots, it registers, I can do that. Okay, CPU offloads. But the GPU is not as fast as the CPU would be. So disabling the GPU would improve the performance and the user experience for some of the workloads,
But
while
not all of them.
others would no. Others would crash without the GPU, like an OpenGL or
Yep.
some of the video examples. They would simply not work. And this is like, oh, what am I supposed to do now?
Yeah,
So
yeah,
I think
yeah,
it's a tricky situation also for the hyperscalers because they
yeah.
have to make a decision on what GPUs they want to buy and
Mhm.
then get them
Yeah,
up
because
and
it's
running
it's not like
in their data
us.
centers.
It's not like us. Even if I was running an IT shop somewhere and I go, I'm buying GPUs for my physical machines because I've got 1,000 VDI users that we need it.
Yeah.
They're not buying for 1,000 users.
No, they're buying
Hundreds
for
of
millions,
thousands,
hundred
millions, right?
millions.
They're running factories dry if they buy one. If they go, we want this model, they're taking them all.
I mean, the number that goes around is like EUC, the number of EUC users is roughly 100 million.
Yeah.
And the number of users using traditional business PCs on Windows is like 750 million, plus
Wow.
another 750 million like consumers.
Now that's
Uh,
interesting. 750 million business users.
yeah,
That's an interesting number because
that's a huge. Just do the math. If Microsoft wants to succeed there and they want to make sure like 200, 300,000, 300 million, of these 750 million, they want to migrate to Windows 365 and boot to Windows
and boot to
365.
it. Yep.
Can you imagine what kind of logistics is behind?
Yeah.
Well,
Their cloud data centers aren't big
yeah,
enough right now.
yeah.
And I mean, they're big, but 300 million, That's a lot of
That's
VM.
all.
And that's,
And I needed, and it's the same problem for Amazon. It's the same problem
yeah,
for Google. So there's no difference. And Ruben and I, we found out that the GPU generations that we find in the cloud are 2 to 3 years behind
yeah,
what we can buy if we go out now and buy a GPU.
yeah.
So if I have, and I have here like a 7-year-old high-end GPU, I can beat this GPU with a cloud VM fairly
Mm,
easily. Even though there's like a 50 millisecond latency to the closest Azure data center from my lab here,
yeah,
but it still is, the performance is better. The user experience is better compared to my physical
yeah.
machine that 8 years ago would have cost me like 20 grand or
And
25
it's a
grand.
and it's a combination of a number of things, right? It's like the cloud, whatever cloud subscription you're hooked up to has got a newer GPU. The protocols have all gotten so good,
Oh, yes.
right? And the bandwidth available, right? We are no longer at, we're not talking, Mux T1s anymore, right?
No,
We,
no.
we have a significant amount of bandwidth for individual users. And that, even though it's an old physical machine that you're beating it, they're showing it being better performance. That is an impressive thing, right?
Yes.
It's
Yes.
because I don't think that was reality. Go back 5, 6, 7 years. I even think the protocols on the video side weren't as good as they are today. I mean, we've seen a whole change, like the way Blast went through its change, and no more PC over IP. We're going to do all the stuff that VMware did. But it's a combination of things that bring that together to make that viable, to make that cloud thing viable. I don't think 5, 7 years ago that would have been viable.
That is true. But to your point, some of the CPUs are good enough, in particular when we're looking at the standard Office applications. So that works really nice. So there's no problem with Windows 365, even though there's no GPU available for that kind of workloads. It's wonderful. And it's always on, and it's very convenient.
Yeah, that whole line of conversation just it just made me think of do you remember the old panel clients? Those little
Mhm.
boxes?
Yep.
And remember, they were like, they kept trying to say we're not a remoting protocol, right? That they were a protocol
Yeah.
that extended the PCI bus. When you talk about Microsoft wanting to make these endpoints that'll do, boot to Windows 365, we've solved the video problem or got close.
Yeah.
We can do audio pretty well, right? I
Yeah.
mean, live video in high def back and forth over it can be an issue.
Yeah,
Peripherals,
synchronizing them
yeah,
is a challenge sometimes.
yeah, and peripherals will be interesting in that
Yes.
world, right?
Yes.
Because then it becomes no longer just about video, right? It becomes about, can I plug this USB device into my
Yeah. Yeah.
whatever my endpoint is or whatnot. But that's neither here nor there. I wanted to hear about it. So this is unbelievably interesting to me. Do you have any upcoming presentations, speaking slots anywhere?
Yeah,
If people want to go hear about it?
next week I'm going to be in Switzerland at Workspace Ninjas.
Okay.
And there are going to be a couple of other upcoming presentations in Europe. I submitted a proposal for Microsoft Ignite in November or December. I think it's in December.
Mm.
I don't know if they will accept me because it's a demo session and I wanted to demonstrate exactly that, like side by side, and how to compare these things and how
That
to
would
make
be
an
cool.
educated decision. So not about rocket science. Yes, it is hard, like you said.
Yeah.
It's hours and hours, days and days, weeks, at nights to collect all this data, and it's not very exciting, I can tell you,
Yeah.
because you're running the same kind of workloads again and again on different machine types and under different network conditions. And I'm able to do one of these like test sequences within an hour or an hour and a half. But there are more exciting things that I could do.
I think Benny just said science wasn't exciting until the Mythbusters.
No. And it reminds me of my time when I was in science, because
Yeah.
you present the results in the end after you were in the lab for a year.
Yeah.
and then you're on stage for an hour and you present all these results.
It comes
And
down to
being
that
on
1
stage is
hour.
the exciting moment after 1 year of
Yeah.
work. And that's the same thing again.
Dude.
So that's what I wanted to remind people. If you want to do what I do, yeah, you got to be patient. You got to be like a wildlife camera person, because
Yeah.
sometimes you wait for a week or 2 or 3 until you get
To get
that
that one
one little
shot.
sequence. Yes, yes, yes. And if you look job description for wildlife camera people, it's very interesting that
Oh,
they
I am putting that in Google as soon as we hang up.
like uh, it's
God,
so interesting. If you look at the
oh
job
my
description, it really
camera.
says you got to be patient and you got to be the one who gets up first because you want to film the sunrise, and then you got to go to bed last because you need to make sure that the batteries are charged and everything. And I was like, oh my goodness,
Dude,
this sounds like
technicians
my job.
technicians will be responsible for maintaining 150 remote cameras collecting data about elk and carnivore
It-
populations.
yeah.
Technicians' duties servicing 150 cameras, maintaining batteries in the study area. On an average day, a technician should expect to hike between 6 and 15 miles and go up and down 5,000 foot in elevation. Okay, they need scientists that are Army Rangers. That's what they need.
Yes. That's what I thought when I read the job descriptions. Like, oh, we sent you out there with a camera. Good luck, survive. And hey, you're never going to be in front of the camera because we fly in the main actor and he's going to act a little bit and nobody will ever see you.
Oh my God. I love it, Benny. I love it. I
And
love,
that's
dude,
pretty
I love,
much my role. I'm doing that in
yeah,
my lab here. I'm
yeah,
sitting down here. It's in the basement of our house. Yeah,
dude.
that's my
I love it, man. Dude, I appreciate you getting on. I think that more people need to see what you and Ruben has presented.
yeah,
If they can get this, did you say Switzerland? Is that where you're headed?
Switzerland. Yeah.
Switzerland. If they can get there, are you going to do any online webinars at any point?
Yeah, we could do something together
Maybe we
even.
should. Maybe what we should do is
Yeah.
sponsor a webinar or something, and get you to do
Um,
a
and
GPU performance webinar or something.
and the thing is that what I typically do when I do these webinars, I put the side by side videos on my website. So because it does
Yeah, yeah.
not look nice when we do that through Zoom or Teams or any of those, and
Oh, and you just you tell them go and
I just give people the link and they click on it, and it's an HTML5 player, so it runs natively on their machines
oh,
and they
great
can
idea.
real
Great
experience,
idea.
compare it, and
Yeah, because when you recorded the end user one, you recorded it from their perspective. I remember when you
yes,
showed that, and you could tell it, you could see everything.
yeah, I use a frame grabber,
Yep.
and if I have a full HD resolution on the main screen, then I record it at full HD, 60 frames per second. So and Ruben started recording everything at 4K. So we need specific frame grabbers that support 4K and allow us to record those videos, MP4s, at this resolution.